So I would like to just answer this viewer's question. We are going to be integrating square root of x squared plus 1 over x. So firstly, notice that we have x squared plus 1 instead of the square root. So, trig substitution. Yes, it's a good idea. U sub is not going to work out nicely because the x is on the bottom. So, let's try trig substitution. So pick x to be what though? Well, we have three choices, right? Sine, tangent, or secant. Which one? Well, the answer is because we have the plus here, so it's going to be tangent. And notice that this is just a plus 1, so we just need to put a 1 right here. If this is a plus 4, then take the square root of that, and we get 2, right? You should put a 2. If it's a plus 16, then you put a 4. If it's a plus 25, you put a 5, etc. And then, of course, we have to do the usual business to get the dx. Take the derivative of this. We get secant squared theta d theta. And now, we are going to take this integral to the theta world. So, we will have the integral. The bottom here is tangent theta. The top is square root. X is tangent theta. But we have to square that. And then we add 1. And the dx is secant squared theta d theta. Now, this is actually very nice because this right here is equal to secant squared theta. Well, we have a square root and then a square. We can cancel them, right? Yes, and usually we will have to put an absolute value around the expression, but I will just tell you this. Whenever we're doing this kind of integrals, whenever you are canceling out the square root and then the square in a trig substitution situation, you don't have to worry about the absolute value. Just trust me, or you can check out my other video for a detailed explanation. Right here, just trust me. The answer for this, just use secant theta. Okay? So it's just the first power. And then, I know we still have a secant square right here. I'm actually not going to multiply with that yet. I'll just write this down, and I'll tell you more about it. Now, if you multiply secant and secant square, we will get secant to the third power over tangent. How do we integrate that? Well, yes, we can write everything in terms of sine and cosine and continue from there, but I'll tell you, it's not so easy, in my opinion. So let's try this right here. Remember, the hardest part when you are doing trig integrals is to know when are we ready to integrate it. And I call them integral ready forms. Definitely check out this file if you haven't seen my previous video. Here's what we are going to do. Notice that we have tangent. I'm actually going to rewrite the secant square back to tangent squared theta plus 1. So I'll keep this, but this right here is tangent theta plus 1, well, with a square here, and then over tangent theta. And the reason that I did this is because I want to pair this up. And I'm going to divide, because tangent square over tangent is just tangent to the first power. That we can handle. Especially we have a secant in the front. We get this right here being tangent to the first power. And then we have 1 over tangent. So far so good. Have a look. If we distribute it, that first part, we can integrate it. Right, that's one of the integral ready forms. Okay, next, if we distribute this to that, we will have secant on the top over tangent. That is kind of hard to handle. That's not in one of the integral ready forms. So, right here, I really have no choice but rewrite everything in terms of sine and cosine. Remember, secant theta is 1 over cosine, and then 1 over tangent, we can write that as cosine theta over sine theta. When we take this, multiply with that, it's the same as taking this, multiply with that. Cosine theta cancel, we will just have plus, and that's going to be sine theta on the bottom, and then on the top, we just have a 1, like this. And of course, this is the same as cosecant theta. And in fact, this is one of the integral ready forms. I'm just going to write this real quick. Okay, we can integrate this because we know the derivative of secant is secant theta tangent theta, so that is just secant theta. Now, the integral of cosecant theta, you will need to know the standard result, and it's a little bit tricky because we have two possible answers for it. Let me write this down. Note, if you are integrating cosecant theta, either you can say that is negative ln absolute value cosecant theta plus cotangent theta. That's fine, of course, the plus c. Notice this is kind of similar to the standard result of the integral of secant theta. The inside is positive, but the outside is negative. However, you could also write this as positive ln, but you will have cosecant theta minus cotangent theta. I know the plus c right here. They are equivalent. You can prove it because this right here is a -1. Put that back to the exponent. You have this raised to a -1 exponent, meaning you get ln of 1 over that. And then do some trick business. You can see 1 over this is equal to that. So they are equivalent. And you can try that out. I'm going to write this right here for my standard answer for that. So that will be negative ln absolute value cosecant theta plus cotangent theta. I'm not done yet, so that's why I haven't put on the plus c, even though it's on my shirt already. But anyways, though, I don't know if you guys are going over cosecant theta in your calculus 2 class or not. Do you have to remember this or not? I don't know. For my class, I don't really ask the students to remember this anymore, like the co-functions, the cosecant, cotangent, not so much. But you do have to know the... Well, let's talk about it later. Let's just finish this. Now, not done yet because we haven't gone back to the x world. So, in order to figure this out in terms of x, we look at this. We know that tangent theta was defined to be x. We can write it as x over 1. And then draw a right triangle. Put the angle theta here. Tangent is opposite over adjacent, so it's x and 1. For the hypotenuse, you open the square root, square this, plus square that. And now you're ready to do whatever you need to. Here we go. Secant theta is opposite, it's a hypotenuse over adjacent. So it's just square root of x squared plus 1. 1 squared is the same as 1. Continue, we have the minus ln absolute value. Cosecant is hypotenuse over opposite. So that's square root of x squared plus 1 over x. Cotangent is adjacent over opposite. So that's plus 1 over x. You do need to have an absolute value here in case x is negative if you have like values. Yeah. Anyways, we're done. Of course, you can put them together, but I'm just going to leave it like this for you guys. And that will do it.